Good morning students, welcome back to my channel. Hopefully you all are preparing well for your board exam. Today we are going to discuss some numericals based on the combination of the resistors. So the first numerical is, in the circuit shown below you have to calculate the equivalent resistance between the points A and B. So the circuit is given to us. एज यू कैन सी क्लियरली बच्चे, हमारे पास इस सर्किट में 4 रजिस्टर्स गिवन है. फर्स्ट R1 6 ओहम, R2 R3 एंड R4. ऑल ऑफ दीज आर ऑफ द 6 ओहम. वी हैव टू फाइंड द equivalent resistance or the total resistance across the point A and B. Let's see how can we solve it. So बच्चे, we will break this circuit into the two parts, that is first from A to C, then from C to B. First we will discuss about the point A to C. बच्चे, as we start from the point A, which I have already told you, you can take any point. Let us say we can start from the point A. So the current as soon as will start from flowing from the point A, at the point A, when it starts, it will get break into the two parts across the resistance R1 and R2. Okay, so whenever the current gets divided, then we can say our combination of the circuit component will be in the parallel. Hence R1 and R2 are in the parallel combination. So the equivalent resistance which we have denoted, Rp1 is equals to 1 upon R1 plus 1 upon R2 is equals to 1 upon 6 plus 1 upon 6 will come out to be 1 upon 3. As we have taken the reciprocal, so after the reciprocal we will get the equivalent resistance across the resistors R1 and R2 is equals to 3 ohm. Now we will start from the point C to B. As you can see, if we start from the point C to B, again at the point C, when the current will start moving, it will get divided again into the two paths. One is from the R3 and other is from the R4. So whenever the current gets divided into two or the more parts, we can say that the resistors are connected into the parallel. Hence R3 and R4 are in the parallel combination. We can solve it as 1 upon R2 is equals to 1 upon R3 plus 1 upon R4 will come out to be 3 ohm. Hence the new circuit diagram for us will become, that is from A to B. First is the equivalent resistance which is Rp1, which we have found out, that is Rp1. Now from the point C to B, it's come out to be again, that is Rp2 is equals to 3 ohm. Hence the equivalent resistance is Rp2. Now we can see clearly in this new circuit diagram, when you move from the point A, the current will not get divided across any point. Instead, it will move straight from the point A to the point C and then to the point B. So whenever the current will not get divided in between any path, then we can say that the resistors are connected in the series combination. Hence the equivalent resistors will come out to be Rs is equals to sum of the first equivalent resistance plus sum of the second. Hence 3 ohm plus 3 ohm will give you 6 ohm. Now we will solve the second numerical, which asks what is the current flowing through each of the resistors A and B in the given circuit. So as we can see that we have the circuit in which we have the two resistors. First is at the point A, second is at the point B, which are connected with the battery, which is at the potential difference of 2 volt. What we need to find out? We have to find out the current across the resistor A and as well as across the resistor B. Let's start. So we know that bache, whenever the current flows from one point to the another point, of course if the current flows from this terminal, then we will move in the direction, and again we can see at this point the current get divided. First part goes to the resistor B and the other part goes to the resistor A. As we have learned in the previous question also, whenever the current gets divided in the two paths, then the combination is said to be in the parallel combination. So the total resistance will come out to be 1 upon R is equals to resistance across the A plus resistance across the B, which is 1 upon 1 plus 1 upon 2 is equals to 3 upon 2. Hence, the resistance is equals to 2 upon 3 ohm. That is the equivalent resistance of the complete circuit. Now we will find the total current across the circuit. So we know that from the Ohm's law, I is equals to V upon R. What is the potential difference given to us? That is 2 volt. We will substitute the value 2 volt. The resistance, that is the total resistance we have found, which is 2 upon 3. Hence the current will come out to be 3 ampere. But the question asks that how much current flows across the resistor A and B separately. Okay, so what we will do, we will find the current through the resistor A. Again, by applying the Ohm's law, we know that I is equals to V upon R. Potential difference, because the potential is same across the parallel combination, hence it comes out to be I is equals to V upon R. V is equals to 2. Resistance across the point A is 1. It is 2 ampere. Now current through the resistor B, which is again V upon RB, is equals to 2 upon 2. Hence we will cancel it out and we will have 1 ampere. Now coming on to the third numerical, which is very important. Consider 3 resistors of 6 ohm, 3 ohm and 2 ohm are connected together, so that the total resistance must be greater than 6 ohm but less than 8 ohm. You need to draw a diagram to show this arrangement and also calculate the total resistance. So बच्चे, in this the question has asked कि आपको 3 रेजिस्टर्स दिए गए हैं, 6 ओहम, 3 ओहम और 2 ओहम को. आपको इन सबको इस तरीके से कनेक्ट करना है ताकि जो टोटल रेजिस्टेंस आए वो 6 ओहम से तो ग्रेटर आए बट 8 ओहम से लेस आए. अगर तो मुझे 6 ओहम से ग्रेटर चाहिए, इट मीन्स 6 ओहम रेजिस्टर जो मुझे दिया गया है, इट हैज़ टू बी कनेक्टेड इन द सीरीज़, बिकॉज उससे मुझे क्या चाहिए, ग्रेटर चाहिए टोटल रेजिस्टेंस. नाउ आई एम लेफ्ट विथ 2 ओहम एंड 3 ओहम. कंसिडर अगर मैं 2 ओहम, 3 ओहम और 6 ओहम इन सभी को सीरीज में कनेक्ट कर दूँ, सो आई विल हैव द टोटल रेजिस्टेंस कम्स आउट टू बी 6 + 3 9, 9 + 2 11, जो हमारे पास 8 ओहम से क्या हो जाएगा, ज़्यादा हो जाएगा. सो सम हाउ आई विल कम टू द पॉइंट कि 2 ओहम और 3 ओहम दीज आर नॉट कनेक्टेड इन द सीरीज, हेंस द कॉम्बिनेशन विच वी हैव लेफ्ट इज parallel. Okay, so we will connect 2 ohm and 3 ohm in the parallel combination. Now for the circuit diagram, for the question like this, we will use the hit and trial method. Okay, so the resistance R1 is 6 ohm which is in the series combination, and the resistance 2 ohm and 3 ohm are in the parallel combination. Now it will be easy for us to solve it. First we will see that R2 and R3 are in the parallel combination. So R1 upon RP is equals to 1 upon R2 plus 1 upon R3 is equals to 1 upon 2 plus 1 upon 3, which comes out to be 5/6. रेसिप्रोकल कर देंगे, which is 6/5 is equals to 1.2 ohm. Now this complete equivalent resistance will come out to be 1.2 ohm. We are left with the resistance R1 and the equivalent resistance 1.2 ohm. So the 6 ohm and 1.2 ohm are connected in the series. Hence the new equivalent resistance will come out to be RP plus R1 is equals to 1.2 plus 6 ohm, that is 7.2 ohm. The fourth numerical asks, what is the equivalent resistance between the point A and B? Okay बच्चे, as you can see the circuit diagram, it is quite confusing because somehow you will not be able to decipher and you will not be able to confirm that the resistors R1, R2, R3 or R4 are in which type of the combination. So I told you so many times कि बच्चे you will take any one point. Let us say I have started from the point A. If I have started from the point A, then of course from the point A, whenever the current will start moving, it will get divided into the two direction. First across the R1 and second across the R4. So if the current gets divided into the two direction and it will flow from the R1 same current, R2 again same current, and R3 again same current. So I can confirm that R1, R2 and R3 are in the series combination. Let's draw it. If I is the current or I1 is the current which gets flown from the resistors R1 of course it will not get divided into any other path. It will again flow from the resistor R2, then resistor R3. Okay, that is I1. Now but from the resistor R4, because we have started from the point A that is having the current I, it is divided at this point, which is I1 across R1, so we can take I2 across the R4. So in all of these three resistors the current is same, that is I1. So I can say that R1, R2 and R3, these three resistors are in the series combination. Hence Rs is equals to R1 plus R2 plus R3, which comes out to be 2 ohm plus 2 ohm plus 2 ohm. It is 6 ohm. Now the equivalent resistance of all of these three resistors is 6 ohm. Okay, so these three resistors and the fourth resistor now in the parallel combination. It is 1 upon Rp is equals to 1 upon Rs plus 1 upon R4, which is 1 upon 6 plus 1 upon 2. Hence our answers will come out to be 1 upon 3 over 6, which is Rp is equals to 6 upon 4. Because we have reciprocated that term, it comes out to be 1.5 ohm. Our answer will be 1.5 ohm. Thank you so much. Stay tuned with my channel.